They called it the machine with too many wheels, a futuristic locomotive unleashed by the Pennsylvania Railroad to outrun the diesel tide and reclaim the crown for steam. On paper, the T1 duplex smashed records, producing over 6,500 horsepower and reaching over 100 miles per hour. Yet within a decade, every single one was gone, erased as if its promise was a myth. How did the most advanced steam engine in America become its fastest failure? The truth starts with a railroad in crisis, desperate for a miracle. By the late 1930s, the Pennsylvania Railroad was running out of options. Its famous K4s Pacifics, once the pride of the fleet, struggled to keep pace with the swelling weight and speed of modern passenger trains. Every year brought longer consists and heavier cars as travelers demanded more comfort and amenities. The K4s, with their 4-6 two-wheel arrangement, had been the backbone of the Pennsylvania Railroad's passenger service for decades. But on the main line stretches between Harrisburg and Chicago, these engines were reaching their limits. Timetables grew tighter, yet the Pacifics could barely hold schedule, even double-headed. Meanwhile, rival railroads were fielding larger, more powerful engines, Niagaras and Northerns, while experimenting with diesel-electric locomotives that promised cleaner, simpler operations. Inside the Pennsylvania Railroad's boardrooms and shop floors, the pressure was mounting. Incremental tweaks to the K4s, such as bigger boilers and improved steam circuits, no longer delivered the gains the railroad needed. The old approach of stretching existing designs had hit a wall. The Pennsylvania Railroad, known for engineering boldness and a stubborn streak of independence, refused to simply copy what others were doing. Instead, it looked for a leap forward, a locomotive that could not only pull heavier trains at higher speeds, but do it with a level of smoothness and efficiency that would silence the diesel threat. The answer would not be found in more wheels or brute force alone. It would require a radical rethink of how steam power could be delivered to the rails, and whether the old rules of locomotive design still applied. As traffic surged and the stakes grew higher, the search for a new solution began in earnest. The T1's shape was unlike anything else on American rails. At first glance, it looked like a streamlined bullet, all sweeping lines and bold curves, wrapped in a sleek shell designed by Raymond Loewy. But beneath that iconic shark nose profile was an engineering gamble, the 4444 duplex drive. Instead of one long set of driving wheels, the T1 split its power between two pairs, each with its own cylinders and rods. This arrangement allowed for lighter moving parts and promised a smoother ride at high speeds. By dividing the workload, engineers hoped to cut down on the pounding, known as hammer blow, that plagued traditional steam giants and battered the rails at full throttle. Loewy's shell was not just for looks. The streamlined casing reduced air resistance, crucial for a locomotive designed to cruise at triple-digit speeds. Every detail, from the recessed headlight to the flush rivets, was meant to signal modernity and motion. The T1's proportions were dictated by function as much as style. The two driver sets, set far apart on a rigid frame, gave the locomotive an elongated, almost futuristic silhouette. The four pairs of drivers spun independently, each set capable of gripping the rails with less weight per axle, making the engine lighter on its feet while still delivering massive power. Everything about the T1's design suggested a machine built for speed and elegance. The independent driver sets, the reduced reciprocating mass, the wind-cheating shell all pointed to a new era of steam, one that could meet the challenge of diesels head-on. On paper, the T1 promised to combine the best of both worlds, the brute force of steam and the streamlined efficiency of the future. Numbers from the test plant at Altoona left no doubt about what the T1 could do. With its four cylinders working in tandem, the locomotive produced an indicated 6,552 horsepower, more than any other passenger steam engine in the country, and even outpacing the Union Pacific Big Boys' legendary output. At 100 miles per hour, the T1's 8 driving wheels spun at 420 revolutions per minute, while the engine moved over 850 tons of passenger train across the Pennsylvania main line. The T1's mission profile was ambitious. Haul nearly 900 tons from Harrisburg to Chicago, with just a single coal stop along the way. On the test stand, the T1 delivered over 6,000 drawbar horsepower above 55 miles per hour, a figure that put it in a league of its own. Engineers calculated that a single T1 could outpull a 4-unit EMDFT diesel, consist at any speed over 26 miles per hour, a direct challenge to the new order of diesel power. The locomotive's poppet valves and duplex drive system allowed it to breathe freely at high speeds, pushing more than 15,000 cubic feet of steam through its cylinders every minute. Stories from the main line quickly spread. Crews and rail fans claimed to have clocked a T1 at speeds well above 120 miles per hour on the flat stretches of Ohio, timed by stopwatch over mileposts. While no official record was ever filed, and the 141 miles per hour figure remains unverified, the T1's ability to sustain triple-digit speeds was never in question. On paper and in controlled tests, the T1 was every bit the speed demon its designers had promised, standing as a bold answer to the diesel threat and a testament to the raw potential of late-era steam. Pennsylvania Railroad's leadership didn't wait for certainty. After just a few controlled tests and limited mainline runs, the decision was made. 50 more T1s would be built, rolling off the lines at Baldwin and the railroad's own Altoona works. The prototypes 6110 and 6111 had barely stretched their legs, accumulating less than 20,000 miles each by most accounts before the order was finalized. That kind of mileage might reveal a few quirks, but it would never expose the full range of problems that could surface in daily, real-world service. Still, management pressed ahead, drawn by horsepower figures and the promise of a steam-powered comeback. This was not a cautious, phased rollout. The production order represented a massive financial BET, with each locomotive costing around $250,000 at a time when dieselization was already gathering momentum across the industry. Baldwin and Altoona split the work, with the last steam locomotive ever built at Altoona leaving the shop in June 1946. 52 engines, all based on the brief experience of 2 prototypes, were pushed onto the main line. There was little appetite for second thoughts or slowdowns. The T1s weren't just experimental anymore, they were the new face of Pennsylvania Railroad's passenger service, ready or not. T1 locomotives rolled out straight into the heart of Pennsylvania Railroad's most demanding passenger assignments. They took charge of the Broadway Limited, the General, and the Trailblazer, trains that defined speed and prestige along the Harrisburg to Chicago corridor. Out on the flat, arrow-straight stretches of Ohio and Indiana, the T1s showed what they could do. Some units logged over 8,000 miles in a single month, a figure that rivaled the best-performing diesels of the era. Service logs from 1946 and 1947 track the relentless pace. Day after day, T1's hauled heavyweight consists at sustained high speeds, keeping tight schedules and making up lost minutes across hundreds of miles. Operating crews, many with years behind the throttle of K4s and M1s, found themselves at the controls of a machine that seemed to leap forward at the slightest touch. Engineers reported that the T1s could launch a fully loaded passenger train with a surge of power, climbing to 80 or 90 miles per hour in a matter of minutes. On paper, the T1 was built for these very conditions, and in these early months, the numbers backed up the promise. The railroad pressed the fleet hard, determined to prove that the investment in advanced steam would pay off in real-world performance, not just in test stands and boardroom projections. For a brief window, the T1s stood at the head of the line, delivering the speed and power Pennsylvania Railroad had demanded. Engineers called it the bucking bronco. The T1's power, split between two sets of driving wheels, was supposed to deliver a smooth, unstoppable rush down the rails. Instead, it brought a kind of terror few railroaders had faced before. Out of the yard, with a heavy passenger train behind, a careless hand on the throttle could send the front or rear drivers spinning wildly while the rest of the locomotive still dug in. The result was not just lost traction. It was a violent, stomach-churning lurch as the whole locomotive shuddered while 8 giant wheels fought for grip. Veteran engineers, used to the steady pull of a K4 or M1, found themselves riding a machine that could turn unpredictable in a heartbeat. At low speeds, the T1 would break loose without warning, wheels flashing and sanders blasting, the cab filling with the roar of steam and the sickening jolt of lost momentum. At speed, 60, 70, even 80 miles per hour, a slip could feel like the floor dropping out from under you. The only defense was to chop the throttle instantly, then coax the power back, praying the wheels would catch before the train lost time, or worse, before something broke. Crews swapped stories in terminals and lunchrooms. One called it riding a wild horse. Another said it felt like the locomotive was trying to tear itself apart. The fear was real enough that some engineers eased off the throttle, holding back the T1's full power to avoid another white-knuckle episode. On paper, the T1 was a thoroughbred. In the cab, it sometimes felt like an untamed animal, and everyone who ran one learned to respect the danger in its design. Shop floors across the Pennsylvania Railroad quickly became bottlenecks for the T1 fleet. The Franklin poppet valve gear, meant to give the engines a high-speed edge, brought a steady stream of failures instead. Valve stems fractured under the pounding of triple-digit speeds, sometimes after only a few weeks in service. The fix was never simple. Crews had to drop heavy gearboxes from between the locomotive's frames, a process that could tie up a bay for days. The streamlined shrouds that made the T1s famous on the main line turned into barriers in the shop, forcing mechanics to remove panels and crawl into cramped spaces just to reach basic components. Every hour spent wrestling with the poppet gear was an hour the locomotive sat idle, earning nothing for the railroad. Parts shortages and unfamiliarity with the Franklin system only made things worse. Some shops had the right tools and know-how, but many did not, and the result was a backlog of T1s waiting their turn for repairs. The promise of cutting-edge steam technology faded fast when every trip to the shop risked becoming an extended stay. With each breakdown, the T1's reputation for reliability slipped further, and the cost of keeping the fleet moving began to pile up. Coal and water bills for the T1 locomotives arrived like clockwork. And they were never small. Each locomotive could carry over 60,000 pounds of coal and nearly 20,000 gallons of water. But on a hard run, those reserves vanished quickly. The duplex drive and poppet valves, meant to squeeze more work from every pound, failed to deliver the savings that had been promised. Instead, crews found themselves stopping for fuel and water as often as with the old K4s, sometimes more. Every mile demanded a steady flow of consumables, and every stop added labor and lost time. Meanwhile, the new EMD diesels rolled past water towers and coal docks without a pause, burning less fuel per mile and skipping the maintenance headaches that dogged the T1 locomotives. Pennsylvania Railroad's finance officers watched the numbers climb: higher coal and water consumption, mounting shop bills, and less revenue service from engines tied up in repairs. On the balance sheet, the T1 locomotive's operating costs outpaced not just the diesels, but even the railroad's own expectations. The promise of economy turned into a steady drain of red ink, forcing hard questions about how long the experiment could continue. In May 1948, Pennsylvania Railroad President Martin W. Clement stood before the press and laid out a new vision for the railroad's future. He announced that all major east-to-west passenger trains west of Harrisburg would soon be powered by diesel. The decision was public, final, and immediate. For the T1 fleet, it was a verdict that came only 3 years after the last engine left the Altoona shops. Within months, the T1s began to vanish from the main line. They were pulled from the Broadway Limited and the Trailblazer, replaced by EMDF units that needed less maintenance, fewer crew members, and no water towers. By the end of 1949, most T1s were in storage or reassigned to lesser duties, their streamlined shells gathering dust in roundhouses built for a different era. No appeals, no last-minute reprieves. The railroad had staked its future on diesel, and the T1s, still nearly new, still gleaming with Loewy's promise, were quietly retired. By 1956, every last one had been scrapped. 52 locomotives, erased in less than a decade, their promise overtaken by a corporate decree and the unstoppable march of technology. Fresh eyes are finding answers in the T1's story that eluded its own era. Today, engineers have run detailed simulations of the duplex drive, mapping how weight shifted across axles as the locomotive thundered down the rails. These models revealed that the notorious wheel slip was not a curse baked into the design, but a problem of balance and control, one that could have been managed with better spring rigging, sanding systems, and crew training. Back in 1946, the Chesapeake and Ohio borrowed 2 T1s for a series of high-speed passenger trials. Chesapeake and Ohio's mechanical staff reported smooth handling at speed and no unusual tendency for the drivers to slip. The T1s made up time between stations, just as the design promised. While Chesapeake and Ohio did not buy any, citing their own shift to diesels, their positive review stands in sharp contrast to the stories from the Pennsylvania Railroad's own crews. Modern analysis, backed by these historical tests, suggests that the T1's core engineering was fundamentally sound. Its most famous flaws were not inevitable. They were the result of timing, rushed deployment, and a lack of long-term development. The problems that once seemed fatal now look solvable, given the right tools and time. In a workshop filled with blueprints and steel, a new T1 is taking shape. Volunteers with the Pennsylvania Railroad T1 Steam Locomotive Trust are building number 5550, the first T1 to rise since the last one was cut up for scrap in 1956. Every plate, rod, and bolt is crafted from original Pennsylvania Railroad drawings, with the benefit of modern metallurgy and engineering tools. This is not just a replica, it is a working experiment. A chance to answer questions left hanging for nearly 80 years. The team is determined to address the flaws that haunted the original fleet. Modern computer modeling guides the spring rigging and weight distribution. Improved sanding systems and state-of-the-art controls promise to tame the notorious wheel slip. The Trust's ambition goes beyond preservation. Their goal is to take number 5550 onto the main line and push for a new world steam speed record, officially aiming to surpass Mallard's 126 miles per hour. For the first time, the T1's potential will be tested not just in legend or on paper, but in the real world, with every lesson of history built into the machine itself. The story of the T1 is not finished. It is waiting at the starting line, ready to show what might have been and what could still be possible. Every year, engineers chase speed and efficiency, yet most breakthroughs still collide with timing, risk, and resistance. The T1's story proves that even the most advanced technology can vanish if it arrives before the world is ready. Today, as railroads reinvent themselves for a carbon-neutral future, its lesson lingers. Innovation alone does not guarantee survival. Adaptation does. What would you risk for a chance to change everything? Let's discuss below.